Okay, today's video is Technology Week 2 on algebra expressions, and today we're going to cover definitions and an introduction to algebra expressions. First, starting out the definition of algebra expressions. Algebra expressions are a collection of numbers and variables connected by addition and subtraction symbols. Here are two examples of expressions. The terms and expressions are separated by plus and minus. For example, this expression has two terms. This is the first term, this is the second term. In this expression, there are three terms. Here's the first term, the second term, and the third term. Terms are separated by pluses and minuses. Now, terms can be considered what are constants. Constant terms are terms that contain no variables. For example, the 3 and the 2 would be constant terms. Variable terms are terms in which there will at least be one letter. So the variable terms here are x, 3y squared, and negative 4y. So you can count the number of terms as well as identify them whether they are variable terms or constant terms. Now, some things that you can do with expressions. You can evaluate expression. Notice the root word has the word value in it, which that's what telling you what to do. You want to put the values in for the variables. And for example, this one says x minus 2 if x is equal to 7. So I'm going to put a 7 in for the x. So 7 minus 2, and 7 minus 2 would be equal to 5. In this second one, we're going to replace the y with a 4, and we'll replace the x with an 8. And then we're going to simplify this according to rules of operation. So 8 minus 3, we'll do the parentheses first, which gives you 5. And then parentheses times it with a number touching a parenthesis means to multiply. So 4 times 5 is 20. Okay, let's look at this example. We're going to put an 18 in for y and add 6, and then put a 6 in for the x. Simplifying the top first, we would have 24 divided by 6, which would be equal to 4. In this next example, we got to plug in numbers for both z and x. So we would have 25 minus 2 cubed plus 1. Now remember, order of operations say you do exponents first. Remember, this means to do 2 times 2 times 2. And 2 times 2 times 2 is 8. So this now becomes 25 minus 8 plus 1. All you have left is addition and subtraction. So starting from left to right, 25 minus 8 is 17. 17 plus 1 would make 18. Now, some more vocabulary words. Within a given term, you have the variable, but then you also have what is called the coefficient. The coefficient is the number that is attached to and it usually is in front of the variable. So for example, in this term 5x, 5 would be the coefficient, x is the variable. If you do not see a coefficient, then it's understood to be a 1. So when you see x, that really means 1x. And of course here the coefficient is negative 7. Here the coefficient is a 3. Now, terms are either considered like terms or unlike terms, and it's important to recognize whether they're like terms or unlike terms because you'll be able to add and subtract like terms. Starting with these ones on the left-hand side, these are all like terms. The best way to think about like terms is that the variable portions match exactly. The coefficients don't have to be the same, but the variable parts have to be the same. For example, in this one, can you see how the x is the same in both parts? The x part is the variable part. These would be like terms. In comparison over here, even though these both have x, this is an x to the first power, where this is an x to the second power, so these would not be like terms. If I look over here, I can see that these three terms, negative 6y, 2y, and y, all have the same variable part. They all have a y to the first as the variable part. Over here, even though the exponents match, they're both the first power, one's an x and one is y, so they'd be unlike terms. Constants are considered like terms because if you look, they both have the same variable part because they have no variable part. Negative 3 and 4 would be considered like terms. Unlike these, because this is a constant, but this has a y. Finally, order does not matter of the letters, just have to make sure you have the same. For example, I have an a and a b squared. This term also has an a and a b squared, even though in a different order, so they'd be considered like terms. This, on the other hand, is unlike terms because this has an a while this has an a and a b.